All right. So, yeah, kind of just wanted to check in, make sure, see if you guys are doing okay. Just some heavy things happened. There were those kind of the threats of a mass shooting on Monday, and then yesterday I heard a student had died in the residence halls. And I don't know. I think sometimes when scary events and tragic events happen, it's good to kind of just take note of where you are and see how you guys are doing. Also, just if you need time and space to kind of just process your thoughts and feelings, feel free to do that. I hope all of you have someone you feel comfortable talking to, whether that's a friend, a family member, or a professional counselor of some kind. I think it's important to know that we're not facing everything alone and by ourselves. And if you have the emotional kind of availability to be there for someone else, I want to encourage you to do that. It does require sacrifice and energy and investment to kind of hear someone out, and there's a balance between giving too much of yourself away but also being completely emotionally unavailable, and it's something that everybody has to kind of figure out for themselves what they're capable of giving and receiving. Well, anyway, I did assign homework 3 for this week. It covers some of the topics we've seen and NumPy and things like that. It's due a week from today, but I just kind of want to be sensitive to what's going on in your lives and on the campus. And so if you need an extension, you can take an extension. I'm not going to demand documentation, which is kind of the normal policy. I'm available to chat during office hours. I'm not a professional counselor or anything like that, and so I'm not exactly sure what I'm able to offer, but I can listen also. I don't know. We'll start there, and if you guys have any comments or thoughts or feelings, feel free to share them. Okay, well, we'll just have the kind of the most abrupt segue, and we'll just say let's take a look at our topic for today, which is on pandas. So the pandas is a library that brings in the DataFrame data structure into Python. So in base Python, there are a couple key data structures that are not present, and we have to import NumPy to have the array. The array contains values where all the values are of the same data type, and pandas allows for us to create the data structure, the data frame. The data frame is basically a table of columns where each column is a NumPy ND array. All right, so each column will contain the same data type, and this kind of allows us to have kind of the traditional data frame where each column is a different variable, and we call this the data frame, and it's very, very similar to data frames in R, and I believe you guys are all familiar with data frames in R. Okay, and so here I've got a few references. And again, the internet is your friend. If you get stuck and you're not quite sure, just type in pandas. How do I this? Okay, how do I do this in pandas? But anyway, there's the pandas. As you write code and things like that, I think you'll come to appreciate well-documented packages. And I'm very, very grateful. NumPy is very well documented, and Pandas is very well documented, and base Python is also very, very well documented. There's a lot of other libraries out there where the documentation just is not very good. But thankfully, these packages are very well documented, and I would say consult the official documentation first before you go straight to someplace like Stack Exchange. And then, of course, after you look at this and you're still not quite sure, you can go to Stack Exchange. But yeah, okay. Anyway, the convention is import NumPy as NP and import Pandas as PD. And this is just kind of, everybody does this. And so whenever you encounter PD in someone else's code, that's going to be Pandas. Anytime you encounter NP in someone else's code, that's going to be NumPy. And that's just kind of the standard fare. But again, the rules of base Python is that you could name this, whatever you want to call it, right? You can call this num-nums and it'll work, but people will just be confused and it'll feel a little bit strange. Does this block what I'm trying to do? Okay. The basic data structure in Pandas is the series. You construct it in basically a similar way as you would construct a NumPy array. There is an additional argument. Okay, so basically the data kind of all has to be of the same data type because it's basically a NumPy array. And then you got this optional argument called the index. And the index is something that differentiates Pandas from our data frames, and it's truly a kind of a wonderful thing. It does require sometimes a little bit more thinking, but I would argue that it's really great. Okay, so anyway, here is a list of floating point values. Okay, 0.25, 0.5, 0.75, 1.0. I throw that into pandas.series. It converts it into a pandas series, and it makes a column. And you can also see it has added another column, and this would be the index that it has added. So it looks at this, and it has added basically kind of like row numbers, but we call this the index. All right, and so here I printed this out. And if you ask, what is, there's two print commands. First is print data, which is this, and that comes with the thing that says dtype float64. But then when you ask, what is the type of this thing that I created, it comes back and it says it's a pandas series. Okay? Pandas.core.series.series, but basically a pandas series there. Again, if you just ask for the data, you didn't print it out, it's going to print out basically something that looks exactly like this. This is just the data output. So again, when you call print in IPython or in Jupyter, you don't get any kind of out here. The out print returns none, right? So there's no out here. Here, this is the out. Okay, series is printed out in table form, and that's the pandas series. There are kind of a few attributes of this series. So you can call data.values, and that's going to be the attribute, the values themselves. Okay, which is basically just the column, and that's going to come back. It's going to come out as a NumPy array. Okay, so this is a NumPy array. From printing only, how can we tell it's a NumPy array and not a list? What?
Is it the brackets?
So lists and NumPy arrays both have the square brackets. The key distinction is what? There's no commas. In a NumPy array, there's no commas between the values. Whereas a list, you got square brackets and commas. So here you don't see commas, so that's going to be your clue that this is a NumPy array. And indeed, if you ask what is the type of data.values, it comes back and it says it's a NumPy ND array. Okay, we can ask what is the index? So the other attribute of a pandas series is the index, and this is it comes back. We get a range index object. Okay, and it's basically like a range, but it's a range that serves the function of index. So start, stop. Step one, it's exactly the way a range index looks, but it's a range index. You can subset a series, a pandas series, just like other Python objects. So you can ask, what is the value at index position 1? So that's going to be the second value in the list. That's going to be 0.5. And if you ask, what is the type here? This is the type. It's a floating point number. because it's part of a NumPy ND array, it comes back as a NumPy float 64, but pretty much it's just a floating point number there. And again, you can slice it just like you would any other kind of iterable structure. So 1:3 will give us the values between the first and third quote-unquote commas, I guess spaces in the NumPy array. And so that works. And NumPy supports what's known as fancy indexing, okay? Basically, you can kind of provide it a list or a tuple of index values, even with certain indices repeated, and it will return all of those values as you requested. So here I requested index position 1, index position 0, index position 1, index position 2, and it returns all of those values in its in a series. Okay, it returns a series with those indices. And so now I've got a duplicate index value, but we're allowed to have that. Okay, again, Pandas uses a zero-based range index by default. So earlier when I created the series, I did not provide anything for the index, and it created the range index 0, 1, 2, 3. Here I am providing a list or a tuple or something of the same length, and this will serve the index. All right, so here I'm giving it letters A, B, C, and D, and so now my index is A, B, C, and D. All right. Just like before, data.values, I've got the NumPy array, data.index. Now it says index is ABCD, right? And interestingly enough, the data type here is not string. The data type comes back as object. And an object basically is the data type that we get in NumPy or Pandas whenever we are dealing with string data. And you might go, well, why don't we use, why isn't it just called string? That would make a little bit more sense to just call string. Well, one thing is that data type object also allows for missing values. And to signify a missing value, you put in basically a not a number, a NaN value, and that will serve as a missing value. And there's NaN value in data type object is distinct from the character string NaN. So you can store the character string NaN, like if you're talking about your grandmother or something like that, but you can also put in the actual NaN object, which indicates that this is a missing value, that I don't know what my grandmother's name is, all right, or something. Okay, so there's a difference there. Okay, again, you can subset based on index position. You can also subset based on, in this case, our indices have names, and so we can say what is the value associated with index name A. Oh, I got my, before I forget, I have to look up your view quiz answers though. I have to look them up though because I don't remember. And then, okay, so you can slice with index position. So this will give us kind of the first two values based on index position. You can also slice based on index names. Now notice what happens when I slice with the names. So normally, when you slice based on index position, it starts at the starting index and it goes up to, but does not include the closing index, right? It kind of goes from the 0 to the second comma, not to the second index position. But when you slice based on names, it's going to start at the starting name provided and go up to and includes the closing name that has been provided. So here, when I say colon name A colon name C, it's going to start at A and go up to and include C in the response. Okay, so here is an example series that we are going to create. But before we get into it, let me go ahead and give you your first view quiz answer. Today's first view quiz answer for week 5 Wednesday is the letter B. B as in bear. B as in bear is your first view quiz answer. B as in bear. Okay, so I have greatly enjoyed the Marvel Cinematic Universe of movies, and so anyway, these were the original Avengers from Avengers 2012. I guess that's 10 years ago now. But anyway, the fictional characters' names, we've got Tony Stark, Steve Rogers, Natasha Romanoff, etc., and we have the actors that played each of these characters. Okay, so that will form kind of the first series, and you can create a series based on a dictionary. So first I created a dictionary using kind of the curly braces. The key is the character name, and the value is the actor name, okay? So here I've created a dictionary where the key is the character name and the value is the actor name, okay? And so when I do this and I say make a series out of the dictionary, so I say pd.series, so pandas.series, and I put the dictionary in there, it comes back and it says, all right, now we've got a series. The data type, the object here, refers to this column, this column of actor names, and that's going to be the data type. And over here, the index is also object type, but the index will be the character names. Okay, index is for the character names. So we've got samples.series are the character names, series.values is going to be the actor names. Okay, these are just some made-up ages. I don't have an exact source, so don't get mad at me if you're a serious fan and you know much more than I do. But we just said, okay, here are the characters, and these are their fictional ages at the time of the first Avengers film taking place in 2012. Okay, and so we have this Thor, who was apparently 1,493 years at that time. Steve Rogers, 104 years, and so on and so forth. This is what we have. Okay, and here I've also created another dictionary. Okay, another dictionary where I've taken each of the character names along with their kind of superhero identities, right? So Steve Rogers is also Captain America, and we've got Black Widow and Hawkeye, and Thor is just Thor. That's his name. Okay, so anyway, these are the series. So I've got different series, and they all kind of have the index and along with values. And so we can create a data frame using that, okay? And so to create a data frame, one of the ways is you can create a dictionary of series, okay? So we're going to have the column name here as actor, and I'm going to provide it the series. Another column name, the hero name, will be the series hero names, and another column age will be the ages, okay? So each of these series, we've got SAMP series, hero names, and ages. Each of these are series, and each of those series have an index. The index are the names of the characters. Now these two series, I think, are in the same order, but this series is not in the same order. Okay, so this series starts off with Tony Stark, Steve Rogers, and ends with Clint Barton, whereas this series is in a different order. Okay, so but that's okay because they all have kind of the index values. Even though the index values are not in the same order, when you say make a data frame out of this, it matches up. It finds the different index values, matches them up accordingly. Okay, so the data frame will match the indices and sort them alphabetically. That's kind of the default behavior. And so when I say make a data frame, which is done by pandas.dataframe, and I'm giving it, again, kind of a dictionary of column names and series, it's going to match them up and do this, right? So we get Bruce Banner, played by Mark Ruffalo. The hero name is Hulk. age 42, so on and so forth, okay? And this is what we have. Okay, and then we say, hey, what is this data type? And it comes back and it says, this is a Pandas data frame. Pandas data frame. Okay, so far so good? Yes, question?
So, like, for example, in like the first dictionary that you made with the like the hero names and their afternames, if you had like one more after that didn't have that wasn't in the ages or the heroes dictionaries, what would come up in the data frame?
Yeah, so here we can let me find, where's my untitled script here? Yeah, so there's different things will result in. I wonder if I have an example of that. Here, let me see if I have an example, and then and if I don't, we'll do exactly what you're asking about. Okay, so another way of creating a data frame is you can kind of create a. So we created this data frame kind of column-wise, right? We gave a column name and the series that goes in each column. Okay. Another way you can create the data frame is you can create a dictionary row-wise. Okay. So you can have we can pretend we're going to have a column of A values and a column of B values, and we can say kind of the first entry, the A is 0 and the B is 0. The second entry, A is 1 and B is 2. The third entry, A is 2 and B is 5. And so here is just this is a list of dictionary values. And then we create, and I say, hey, make a data frame out of this. Make a data frame. Okay. Now, normally the default index would be 0, 1, 2, right? The range index would start at 0. And but here I'm specifying, you know what? I want to take command and I want to create the index 1, 2, 3 instead. Okay, and so we can do that, and we get a data frame with index for the row names, basically 1, 2, and 3. The index is 1, 2, 3, and then the column values are exactly as the rows kind of indicated with our dictionary. All right. So this is a bit of a more painful way to do it, and if you spell things wrong, it's going to give you different entries. So this might address one of your questions. Well, I think your question was specifically about the index. But here I say, here's a dictionary, A0, B0, A1, B1, okay? And here I've got A2 and C5, okay? So when I say make a data frame out of this, Pandas will recognize, okay, we got a column of A values. We got a column of B values, but I don't have anything here. We also have a C, so we're gonna have to create a column of C values. And so when it does that, it barely fits in here, but it fits. We got, so here I didn't provide an index. So the default index will be 0, 1, 2. We've got the column for A, 0, 1, 2. Column for B, 0.0, 2.0, and then nan. And then over here, because for C, there's no C values for the first two rows, so we get nan, and then we get 5.0. Now, notice that over here, column B is what data type? Up in this data frame, column A and column B are both integers, and we can tell they're integers because they don't have any decimal points showing up. Somehow this turned into floating point numbers, and I can tell they're floating point because it says 2.0 and 0.0. Why did it convert to floating point numbers? Yeah, question?
Because not a number is a float.
Yeah, so not a number is a float. There is no not a number that's an integer. Okay, and this is a limitation of Pandas, and so if you're working with R, you can have integers that are missing. You can have NA missings, but in Pandas, missing is represented with not a number, and not a number must be a float. We don't have a missing value for integer type, and so when you have missing values, it's going to kind of coerce, or I'm sorry, not coerce, upcast the data type into floats. Okay, here's another one. Here is a different dictionary. Okay, so this is another dictionary. I've got column names, and rather than providing the name of a series, so these are all multiple ways of creating the data frame, right? So one was we had the column name, I think it was like actor name, and it had the series that we had already defined earlier with actor names, and then we had another series that we had already defined with ages. Here I'm just kind of entering the values directly, but this time I'm entering them column-wise. I'm giving it the column name A and a list of values 1, 2, 3, a column name B and a list of values X, Y, Z, and it creates it exactly as I think I would expect. Okay, here I have a mismatch. When I do this, I have column A has 4 values and column B has only 3 values. And if I say, hey, make a data frame out of this, Pandas comes back and says, I don't know how to do this. I don't know how to do this. Okay, and finally, another way of creating a data frame is by taking basically a matrix, a 2-dimensional NumPy array. And so here I've created a NumPy array with random integers. I say random.randomInt 10. Size, I want 10 of these values, and reshape it into a 5x2, 5 rows, 2 columns. And then I can say, make a data frame out of this 5x2 array. The column titles will be X and Y, and the index names, and again, index is optional here, but the index names will be the letters A, B, C, D, and E, and it does exactly, I think, what we would expect this kind of command to do. Okay, so multiple ways for creating a data frame. Probably the easiest way later is there's a function where you're just going to read in CSV files. Okay, and read CSV is going to create a data frame. Okay, I guess I don't have the example about what do we get if so let me just delete these. All right, so I got import numpy as np, import pandas as pd. So we'll do that, and the question was okay. So let's create series 1, and this will be pd.series. All right, let's do range 4, and we'll say index is going to be A, B, C, D. Let's okay, so that's one series, and then let me just copy this. And I think this was what your question was, series 2. So let's just change this one to E, and then we want to know what happens if I try to make a dictionary out of these two things. What do you think is going to happen? Yeah.
Oh, sorry. I guess D is going to have one empty entry, and B is going to have one empty.
Yeah, I think we're going to get 5 rows, A, B, C, D, E, and we're going to get missing values for the D and the E. Okay, so we'll say PD dot. I forget how to spell data frame. Is it data PD dot capital D capital F? Okay. All right, so we're going to have column X will be. I got to do a dictionary. Column X will be series 1. Column Y will be series 2. Close that off, and then okay. If I do this, it'll create it, and I think we get exactly what we expected, which is 5 rows. It matched up the indices as we wanted or as we requested, and where it didn't find index match, it filled in a nan, and or didn't find an index match, it filled in a nan. Okay, was that your question? What happens? Yes, Julia.
Index like is less than the amount of values. Will it throw an error, or will it try to fill it in?
It will throw an error. Here, let me just. Okay, so here we'll create series 3. So here I got range 4, and you're asking what will happen if I just stopped at ABC? Yeah. Okay. Okay, so so when you have once you've created a data frame, oh, let me go ahead and give you your second view quiz answer for today. Second view quiz answer is D. D as in dog. D as in dog is our second view quiz answer. All right, so the dot columns attribute of a data frame will give you the column names. The dot index attribute will give you basically the index or the row names. So here is Avengers, and I can say what are Avengers.columns, and we're going to get the column names, actor, hero name, and age. And what is the index? And we get Bruce Banner and et cetera, the character names there. Okay, and these themselves are almost like little NumPy arrays, but they get kind of the distinction of being an index. Okay, so you have an index across the columns, and you have an index across the rows as well. And this is kind of how we kind of locate values within the table, right? So, so how do we can select a column by just doing Avengers, the name of the data frame, dot the column name, okay? So this is very convenient, and this is my recommendation is don't put spaces in your column names, because if you do, you can't do this, right? So use underscores, either snake case or camel case, you know, where you just kind of capitalize each new word if you need multiple words and things like that. Okay, so you got Avengers.actor. Now, if you do have a space, you can use square brackets, and you can do this, and this will work. But the dot notation is very convenient, and so I recommend, in general, avoiding spaces in your names. Okay, so you can have spaces, and you can still do your work, and it's not going to break anything. But well, it'll break this. You can't do the dot notation. Okay, and again, if we ask what is its data type, each of these things, each of the columns themselves are series. Whoops. Oh no, I did something. Okay, so this is where we left off. Okay, so when you select a column, you can also index subset based on position. So we could say, what is the index position 1 and the actor column? Okay, you can also ask, you can also subset using some kind of criteria, right? So we could say, give me the actors where the characters had age 42. Okay, and again, looking at the full data set, we had 2 characters who were 42 at the Battle in New York, or whatever we call that thing. Okay, so we have that, and you can also, you know, kind of subset using square brackets. So we can say, basically using the name of the index. So we can say who, give me the value in hero name corresponding to the index Steve Rogers, and we get Captain America. Okay, and again, you can also use colon notation. So we say Steve Rogers through Tony Stark, and we'll get all of these values as well. Okay, so these are Pandas series, and we can subset them accordingly. The dot location attribute. So you can use the dot location attribute from the data frame, and that will subset things based on the index names. Okay, dot location will subset based on the index names. So I say, give me Avengers dot location Thor, and this will give you the row the row corresponding to Thor. Okay. Now, when it comes back, it's going to come back as a series. Okay. So we basically converted that row into a series. The series has the index names, actor, hero name, and age, and we have the values in that row. So when you ask what is the type of that row, it's a series, and the values come back as an ND array. And you go, well, that's strange. That's strange because I thought ND arrays, when you had an array, everything had to be of the same data type, and it sure looks to me that we don't have the same data type, right? We've got a string here, we've got a nan float here, but actually it's not a nan float, it's a nan object type, and we've got, this looks to be an integer here, okay? There is something known as a structured NumPy array, okay? And we didn't get into it, but you can have arrays where you can say the first value is always going to be string type. The second value is always going to be, float type. The third value is always going to be integer type. And you can create NumPy arrays that way, where you can kind of structure them and say this position is always this type, this position is always this type, and this position is always this type. And that's different from a list where you can have mixed types, but you're not going to be able to say like first position is always going to be this type and the second position is always going to be that type. So that's known as a structured NumPy array. We never got into like creating it because I would say we don't often create it manually. It's often kind of the side effect of subsetting a row like this. Okay, you can get the entire column of ages using the .location attribute as well. And this is, you'd say basically give me all the rows. So slice all the rows by providing nothing in front and after the colon operator. And you say give me the column corresponding to age. And again, this is using the row comma column thing, okay? And so when you do this, you get back a series. You can also ask .values, and this will just be the array of the numbers 42, 41, and so on and so forth. Here we have, you can kind of say, I want for row Steve Rogers and column age, what's the value? And we get back the integer 104. Okay. There's another attribute, the iLocation attribute, okay? So you got the .location, .loc, and .iloc. .iloc uses index position, and that's going to be zero indexed, zero indexed index position. So you can say, give me Avengers.iloc3, and this will give you basically the fourth row, the index 3 position, and that's going to be kind of the fourth row. And you can say, give me 0, 1, and that's basically a coordinate of points. The 0 index row, the 1 index column, which I guess the 1 index column was the hero name. 0 index row was Bruce Banner's character, and so we get that. Okay. These things can be used in conjunction with assignment. Okay. So later on, if we wanted to set a value, we could do that. We could say, I want to set the value Thor's age to be 1500. Okay. And then Thor hero name used to be a nan, a missing value. Now we can say, you know what? Let's also call it Thor rather than missing. Okay. So we've updated the values in that row. Okay. Updated the values in that row. In Jupyter, one of the interesting things is when you just type out the name of the data frame, it formats it kind of pretty, where you get this. You can hover over the rows. Whereas when you call print, where did it go? Printing the data frame looks like this. Printing the data frame looks like this, and then when you just type out the name of the data frame, it kind of formats it. Formats it like that. Okay. You can also assign multiple values at once. So here I'm going to say location Thor, and I'm going to give it basically a tuple or a list of the column names. and we're going to give it basically a tuple or list of the values to be assigned respectively, and we can say I want to put Nan back in hero name, 1493 back in the age. Okay. All right. Let's look at what happens when you use .loc and .iloc, and your index happens to be numbers, but aren't numbers starting at 0. Okay. So here I've created this data frame. The data frame index is 1, 2, 3. Okay. So when I say I want the .location 1, this uses the actual index. It's going to be what has index 1, and that's going to be 11 and 2. When you do the .iloc, the iloc always uses a 0-based index. Okay, and it's going to say, if you had numbered these kind of with a range index starting at 0, what is ilocation 1? Okay, index 1. So it's kind of, now when I say index 1, this would be using a 0-based index. Index 1 corresponds to the second row, which would be this, right? So there is a distinction between .loc and .iloc, especially when you have a numeric index that doesn't start off at 0. Okay, so I want to make sure that we understand the difference between these two things. Now, if you have just a range index that starts at 0, that's going to be exactly the same. The .loc and the .iloc are going to behave identically, because if you have a range index that starts off at 0, there's no problem. But these two things do behave differently, and sometimes it's easy to confuse yourself. It's easy to confuse yourself, especially if you have a numeric index and it doesn't start off at 0. Just be careful. Okay, so here, this is what happens when you give it an index. So we have index 3, right? But if you tried to use iloc 3, that doesn't exist, right? Iloc 3 would correspond to the 4th row, which doesn't exist. Oops, I keep clicking the wrong button. What happened? Okay, iloc 3 does that, and we get an index error, right? So we could come back and we say, oh, you know what? This index doesn't work. Okay. Let me go ahead and give you your last view quiz answer. Today's last view quiz answer is the letter A. A as in apple. A as in apple. All right, so here we can subset using Boolean values, right? Boolean kind of thing. So we can say, I want everything in here, .loc, and we want where Avenger's age is less than 50 and Avenger's age is greater than 40. Okay, I want these rows, and the columns I want hero name and age. Okay, I don't care about whatever actor name. And so this is what we get. Okay, so we've subset the rows based on these conditions. As far as the column names, or I'm sorry, the row names, there's other things too. You can also take the index and treat it as a string. So notice the stream of dots. So I'm going to say take Avengers, take the index, which will basically be the row names, convert it to a string. So you can do dot string, okay, dot str, and then there's the method starts with capital B, and that will give us true and false values, Boolean values. And so give me all of the rows here that correspond to this condition being true, and then give me back all of the columns. And we get Bruce Banner. Here's another one. You can say, I want to look, instead of string starts with, we can say string find capital R. All right, and so we're going to have anybody that has a capital R in their name. So we get Steve Rogers, Natasha Romanoff there. Okay. Oh, here, so remember find, sorry, and it's not just find. So find gives us the position, and it will either give us a value And if it doesn't find it in the string, it's going to return -1, right? And so we're going to say we want to find, if we find it, we want to make sure it's not equal to -1. And so this will give us the rows with a capital that have a capital R in them. Okay. Other commonly used data frame attributes, you can take the transpose of a data frame .t. You can ask for the data types contained in the data frames. You can ask for the shape of your data frame. So these are all kind of, I think, straightforward things. All right, probably the most common way getting a data frame into Pandas is just you read_CSV. So you got a CSV file. This assumes that you've got kind of column names in there. You do this, you do read_CSV. You're going to get a zero-based index, okay? And it's going to kind of figure out what the default behaviors. It's going to try to figure out what values are in the column types, okay? And so here I had a bunch of integers for passenger ID. Age was also an integer, but we had things to indicate things were missing for the age. And so when we did that, it kind of upcasts the age into a float. Okay. All right. And so you can ask, what's the shape? 891 rows. What are the column titles? What are the index? What's the index there? Okay. We can call .info. .info kind of gives you not just the column names, but it also gives you the data type of each of those column names. And it will also tell you how many kind of missing values you have, right? So here we can see there's, cabin has quite a few missing values. Age has quite a few missing values. Most everything else, if we have a total of 891 entries, most of them are pretty full. Okay, most of them are pretty full. This one's missing 2 values. Just these 2 rows have stuff missing. Okay, and then the last thing you can do, as far as the numeric values go, you can ask for .describe. .describe will give you kind of your standard statistical functions, the min, max, median, as well as the mean and standard deviation. So it just goes through, it just identifies which columns are numeric type, and it does these calculations for you. Okay. Any questions there? All right. Well, we'll end here for today, and other than that, have a good rest of your day, and we will see you guys on Friday.